All right. So today and for the next several days, actually pretty much from today on, we're going to spend a lot of time talking about what we call proportional relationships and what it means to be proportional. So when we first started ratios and rates, it was day one of ratios, and I asked you guys, how many of you remember what a ratio is? And most of you, I think, kind of raised your hands. I said, well, tell me what you think a ratio is. And started telling me different things. Well, one of the common descriptions that were used when we talked about ratio was the word comparison. Most of the definitions or descriptions involve that word comparison. Okay? Well, I'm going to do the same thing today. And I know you guys have heard the word proportion or proportional. So that's my first question to you. Can anyone describe what it means to be proportional? And I'm going to take one thing off the table right away because I get this every year. And I'm not saying any of you would have given it to me, but I hear it all the time. They mistake the word proportional with portion. Because someone would raise their hand and be like, well, you know, when you're eating dinner, you're only supposed to have, you know, this many portions of this or that. I'm like, no, different, completely different, okay? We're not thinking along those lines. It's proportional. So, any ideas? How many of you have heard the word before? Like, yeah, you just said it, heard it. Prior to me, most of you have heard it, okay? So what do you got? What do you think, Leah? Even on both sides? Okay. No, I like that. Keep going. Yeah, there are a lot of different ways to describe it. And I know what she means. I wouldn't word it exactly like that, but I know exactly what she means. It's good. Ellie? Mm-hmm. Yeah, we solve proportions is what we would do. And it would be something like 1 over 2 is equal to 2 over what? Right? And that would have to be proportional. And that goes back to what Leah kind of just said. It's like even on both sides because 1 over 2 is equivalent to 2 over 4. Got it? Okay. Mikey? Balanced one way or another. Okay. They don't have to be the same, he's saying. All right. Good. Hayden? They could. Like we were saying, like 1 over 2 is equivalent to 2 over 4. Right? No, no, no. I know what you're saying. Yeah, I'm not disputing that. I agree with that. Okay. So now if we think of a proportional relationship, and think of it in terms of like a graph. Let me go there. Like if we graph something, which we haven't graphed much this year. We're going to graph a lot more. In fact, this next 2 weeks, we're going to be graphing a ton. All right. Can you think of what a graph of a proportional relationship would look like? Any ideas on that? Finn? Yeah, like a line, like linear, a steady rate, okay? Sometimes people use, instead of the word steady, they use the word constant, like a consistent or constant rate. And that's what we're going with here when we go with proportional. The definition that we're going to use, two quantities that have a constant ratio or rate. And that's what I was getting at there at the end about if you're graphing something, how is it going to look? Physically speaking, it's going to look like a line because they're growing or decreasing at a constant rate. So think about, I'm just going to float out an example to you, something very basic. So something, let's say you're walking on a treadmill, and you're walking on a treadmill at a rate of 3 miles per hour, let's say. Okay, so 3 miles per hour. And you're maybe you didn't follow a diet very well. You guys are too young to worry about diets, but let's say you didn't follow a diet very well over the break, and you're going to be walking for a long time. You want to burn some calories. So if you're following that consistent rate, you walk 3 miles in 1 hour. You walked how many miles in 2 hours? You're going to go for 3 hours. Then you've walked 9, right? That's that constant growth. It's 1 hour is 3 miles. 2 hours is 6 miles. 3 hours is 9 miles. That is constant growth, constant change. That's a proportional relationship. Tell you what isn't a proportional relationship. Let's say you get on a treadmill and you're walking at a rate of 3 miles per hour, and then you're like, this is too slow. Or I got to really start working hard. So you change the pace of it. And then maybe you do the 3 miles per hour for like 5 minutes. And then for the next 5 minutes, you're going at 3.5 miles per hour. And then you're like, you know what? I'm gonna start running. And you crank it up to like 6 miles per hour or whatever, and you start running on it. Okay, that different change, the change in that is not going to create that linear pattern we talked about. It's going to create sort of an arc or an uneven, unbalanced line. Okay, if you're thinking physically here. All right. We have something called a constant of proportionality. In the treadmill example that I gave you first about you walking to burn off some calories, that 3 miles per hour, the constant of proportionality would be 3. Because if you notice at the very end, it references unit rate. Before we left on break, we were spending a lot of time taking rates and converting them into the unit rates. Well, that's what we have when we have a constant of proportionality. In order for a relationship to be a proportional relationship, there has to be a constant unit rate throughout. Okay? So my treadmill example, again, going back to that. I'm measuring time and I'm measuring distance, miles per hour. Okay? If I have a different value, if it's changing throughout, then I don't have a constant of proportionality. But if I have the same value, 3 miles per hour, 3 miles per hour, 3 miles per hour, the whole time, then I have a constant of proportionality, and that would be 3 in that case. Okay? Now the variable here, k, you might be thinking, why k? Sort of the accepted value that we use for constant of proportionality. You're going to see that throughout. I've heard different descriptions as to why we use K. They're like, why don't we use C for like constant of proportionality? To be honest, I've heard people say that, well, C is oftentimes used as a variable in different formulas, so we chose a different value and we went with K. Whatever. All right, that's not for you to worry about. Just know when you see the value K or the variable K that we're talking about the constant. All right, and then the last thing is non-proportional. So if two quantities are not proportional, then they don't have a constant rate or ratio. Let's see some examples here. So look at the table for example 1. Talking about, what is this, a car traveling down a local street. Never mind the fragment there. But a car is traveling down the street, and you're measuring time and the distance traveled. The question is this a proportional relationship? Is this a constant relationship, like constant rate or ratio? In this case, it's a rate. Do we have that throughout? Would you guys say it is? Could you predict what 5 would be? Could you predict what 6 would be? Would this be a linear type graph? A lot of you are saying, yeah, it is. I agree, it is. So the first thing you're going to say here is yes, because it says, is it a proportional relationship? Well, yes, it is. The second thing is, if it is a proportional relationship, then you should be able to So what is K? What is our unit rate? Quentin? Yeah, so I would say I could just go 24, and I'll put MPS here, meters per second. Right, that's your unit rate. You're traveling, or the car's traveling 24 meters every second. Well, the easiest way to find the unit rate is if they've given you the value for 1 right away. This doesn't always happen. But we're saying, okay, 1 second has passed, the car's gone 24 meters. There's your unit rate. Or if you didn't believe that, you kept going, you're like, well, I'm going to look at these other values, 48 divided by 2, 72 divided by 3. All the way through, it's going to be 24. All right, take a look at the next one. Got some baseballs here. So 1 baseball costs $2. 2 baseballs, $3. 3 baseballs, $4. 4 baseballs, $5. Et cetera, et cetera, et cetera. Proportional relationship. Like a smattering of no. Yeah, no? Okay. Well, I'm going to need you to prove that because I'm going to argue that it is. Because I'm just going to say, well, this goes up by 1. This goes up by 1. This goes up by 1. That seems pretty consistent to me. I think I could predict at 5 it's going to cost $6 plus 1, right? How would you defend it? Because I agree, it is not a proportional relationship. Jack? You think this should be a 4 here instead? Okay, because if my argument here, I'm just adding 1 every single time, doesn't support the argument in order for it to be proportional that it must have a constant unit rate. So you're saying this is not a constant unit rate throughout. Okay, so if I erase this, my unit rate looks to be here, $2 per baseball, right? Let me abbreviate there. What's my unit rate here? $2 a baseball? Brandon? Yeah, we're going $1.50 per baseball here. And you don't even have to go any further. You could, but these are going to change as well. So we don't have the consistency that we did here. Remember up here, this was 24 every time. This is not an uncommon scenario, though. You guys have ever seen these deals that they say, well, if you buy 1, it's going to cost you this much. But if you buy 5, let's say, it's going to be a little bit cheaper per item, right? It's like they entice you to try to buy more. So out here, or starting off, it was $2 for every baseball. Here, what is this? $1.25? $1.20. No, $1.25, sorry. So you're getting a deal by buying more of them, but this is not a proportional relationship. All right, last one on this table. Number of drinks versus the total cost. Proportional? No, and this could be like the worst deal ever, right? It's like, okay, before, at least with the baseball, it's like, oh, you're going to buy more? Well, we're going to cut you a deal. You buy 5, all right, that's cost this. This one is like, okay, you buy 1, it's $6. You buy 2, it's now $7 per drink. Oh, you buy 3, we're going to charge you over $7 per drink. Now, it's like the more you buy, the higher the unit price, and that's not true. That is not going to happen. Well, it might happen. It's just not good if it does, okay? So if it's not a proportional relationship, then you can't find a constant of proportionality because it does not have a unit rate, consistent unit rate. Turn that over. All right, here's where it can get a little bit tricky. Because when we talk about proportional relationships, they must follow or follow into an equation that looks like y equals kx. This is the accepted equation that we use for a proportional relationship, where k, again, is the unit rate. Okay, so I'm going to ask you guys something. Maybe you remember this, maybe you don't. You guys remember graphing, of course. Like, you know how to plot points on a graph. Well, when you're graphing two variables, do you remember talking about an independent variable and a dependent variable when you were graphing? Now, if you say yes, it doesn't mean I'm going to call on you. I'm just curious. Do you guys remember hearing that at all at some point? I would have assumed that you've got to that point, right? Well, that's important here. We have to be able to determine what an independent variable is and what a dependent variable is. Okay? Does anyone want to try to describe the difference between them? You want to give it a shot, Amelia? She's backing out, all right? That's fine. Okay, well, how about this? Do you remember which axis, like the X or the Y, do you remember which axis the independent variable went on? Ellie? The X, yeah. So something that I want to review with you is that X is your independent variable. That would make Y your dependent variable. Okay, important. So when you're up here at this equation and you're putting numbers into this equation, the Y would have to be whatever you determine the dependent variable to be. Okay. Nobody wants to give it a shot about what it means to be an independent variable, what it means to be the dependent variable? Go ahead, Mikey. The pounds, okay. And I agree. So I'm gonna actually put a little side note. Pounds in this particular example, I agree. So what was why was that the independent, Mikey? You were right, so you could obviously pick out what the independent is. Describing it, I know, is a whole other issue. That's not easy. Leah? Mm-hmm. Yeah. No, I agree, and that's exactly kind of the way I was going to word it. When you talk about an independent variable, it is not impacted by the other, okay? So when you look at this particular example, I always say to my kids, if you're not sure, then ask yourself this question. I've got two variables. I've got pounds and I've got dollars. You would say, does the price depend on how many pounds of meat were purchased? Or do the pounds of meat purchased depend on the price, the overall price? And if you think about that second statement, it might be a little confusing because it's not necessarily true. The first one is true. The cost depends on how much you buy. It's like, how much does it cost? Well, how many pounds of meat did you buy? That's when I'll tell you the cost of it. So you can determine it based on that. So in this particular case, we want to find the unit rate. So why don't you calculate what you think the unit rate should be? Anybody got a number? What do you think, Finn? Anybody else go with 2.88? Most of us. Okay. So you guys, in order to get 2.88, you divided 720 by 250, or 2.5. So what does that 2.88 mean, Finn? Yeah, dollars per pound. That's your unit rate. Dollars per 1 pound. Okay. Well, does this mean that in order to find the K value, you would take your dependent variable and divide it by your independent variable? Would that work every time? You think? I'm asking the question. I realize you guys have only seen one example, so it doesn't always necessarily work. Well, I'm going to go backwards here. I'm going to go to this first example, which we said was a proportional relationship. So we have time versus distance, and here's something that you guys should always keep in mind. If time is one of your variables, which one do you think it usually is? The independent or the dependent? Quinn? It's the independent, right? Time is going to pass, right? What happens with this car or whatever, time will continue to pass. Car could break down driving down the street. Time will continue to pass. It is not dependent upon anything, all right? But when we measure distance, like how far do you go? Well, how long did I drive, okay? So in order for us to get this amount here, it looks like most of you guys took the distance and you divided it by the time. Or you took the dependent variable and divided it by the independent variable. Well, that's 2 out of our 2 examples that have been done that way. I'm going to show you this. And you guys being experts at solving equations will be able to prove this. If this is the equation, y equals kx, then that means k is equal to what? If I solve this equation for k, k is equivalent to what? No numbers. You're just trying to isolate the variable by getting rid of the x, really. Hayden? Well, I don't ignore all this. This stuff doesn't even exist here, all right? Just if I gave you this equation, said y is equal to k times x, that must mean that k is equal to, Amelia? Y divided by x. If I divide both sides by x, cancels it here, so I'm left with that. That's the rule. So in order for you to find the constant of proportionality, you can always divide your dependent variable by your independent variable. And we just proved it here and on the other side. So your equation should have been y is equal to 2.88x. And then the question is, how much would 4 pounds cost? And your answer to that question would be what? Probably already figured this out. Maybe I'm wrong. Maybe not. Sarah, what do you have? Is that 11:52? Okay. Good. All right. I want you guys to try this next one. We'll finish up after this next one here. So you guys have to do like we did before. Write an equation and then answer that question associated with it. I'm just going to write. You don't have to write everything I write. I'm just going to write out the questions that I'm going to be asking you. So the first thing I would have asked you was, what is your independent variable and what is your dependent variable? Hopefully you can like find the two variables that we're measuring here. JC, what do you think? Okay. All right, so I'm going to go very generic first. So independent is the days, and the dependent would be the dollars, or the cost, okay? And I agree. So it's going to be the 6, and then your 34.50 there. Remember what we just talked about. If you have one of your measures being a measurement of time, in this case days, that's going to be your independent. All right, so what would K equal then? Go ahead, Sarah. 5.75, and that means 5.75. What is that? Dollars per day. Good. So that's a unit rate, and she got that by doing the dependent divided by the independent, the 34.50 divided by 6. All right, so then your equation is y equals k times whatever x is, and now we have an equation that we could just substitute values into. So it's like, well, how much do I owe you for pet sitting? I don't know. How many days do you need me? Right? So it's like, well, it's 4 days, it's 10 days, it's, half a day, whatever it is. All right, you can plug that in for x. In this case, it was 4 days. So how much money is owed? It's not a bad gig, I don't think. Quinn? 23? All right. That's it. Okay, so we just have to get to the point where we can recognize proportionality. Is it proportional? Is it not proportional? And then how in the world do we get this k value? Which we figured out, k is just your unit rate. And if you can find unit rate, you can find the constant of proportionality. That's a good place for us to stop today. All right, we'll pick up here tomorrow.